Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 6. Question number 6, the directions say solve for x. And we're going to solve actually all four parts here, A, B, C, and D. We're going to solve all four of them using a similar method across all four. And there are alternative ways of solving these equations, but we're all going to solve them in kind of the same way. And we're going to be using factoring, all right? Again, there are other ways to solve these equations, but the way that we're going to solve A, B, C, and D all involve some version of factoring. So let's get into it. All right, 6a. 6a says x squared minus 11x plus 30 equals 0. This is a fairly straightforward quadratic equation, all right? And when you're solving a quadratic, especially when your coefficient on x squared, when it's a 1 like this, I would encourage you to check and see, can you factor this? Now, the thing is, not all quadratic equations can be factored easily, right? So it is entirely possible that you might have a quadratic that can't be factored, but it's worth checking, again, especially when you don't have a leading coefficient on x squared. So if you want to try to factor an expression like this, what we are looking for is we are essentially looking for, we're looking for two numbers. You know what, I'll use A and B. We'll just keep it simple. We're looking for two numbers that when you multiply them give you this number, 30, and when you add them together give you this number, which is negative 11. All right, so that's kind of our goal right now, is you want to try to find two numbers that when you multiply them together, you get 30, and when you add them together, you get negative 11. Well, let's think about what that means for a second. If you multiply two numbers and the result is positive, right, because it's positive 30. If you multiply two numbers and you get a positive number, it means one of two things. It means that either the two numbers are both positive, because a positive times a positive is a positive, or both numbers are negative, because a negative times a negative is also a positive, right? So the fact that the 30 is positive tells us that the two numbers that we're looking for, they're the same sign, all right? I also know that when I add them together, I get a negative number. I get negative 11. So if they're the same sign and you add them and get a negative number, it means that both of them are negative, right? So we're looking for two numbers. They happen to both be negative, that when you multiply them, you get positive 30, and when you add them together, you get negative 11. I would encourage you to pause for a second and see if you can identify what those two numbers are. So the two numbers that we're looking for are negative 5 times negative 6 is 30, and negative 5 plus negative 6 is negative 11. So the two numbers that we want are negative 5 and negative 6. What we're going to do now is we're going to rewrite our equation, and we're going to write it in factored form. When your leading term here is, again, when there's no number in front of it, when the coefficient's a 1, then this is just going to be x and x, just like that. And then the two numbers that we found, the negative 5 and the negative 6, well, they go here, just like that. So now we have successfully factored the left-hand side of this equation. Notice that if you wanted to go backwards and from the answer that we got here, not our final answer, but sort of the factored form. If you wanted to go back to the original form, you would use FOIL, right? You would distribute first, outer, inner, last, combine like terms, and you would end up getting the original equation that we started with. So what I have here is I have quantity x minus 5 times quantity x minus 6 equals 0. Well, notice that when you have factored form like this, notice we have a product. right? We have something times something. The first something is x minus 5, and the second something is x minus 6. But they're being multiplied together, right? There's a multiplication happening right there, right in the middle. And we get 0. Well, there's something in math called the zero product property. And the zero product property says that if you have a product, right, which is the result of multiplication, if you're multiplying two things together, or any number of things, and you get 0, the only way that that can occur is if at least one of your factors was itself 0, right? So you can't take a non-zero number, multiply by another non-zero number, and get 0. That's not possible, right? So the only way to get 0 from a product is if one of your factors equals 0. So from this equation, we can say, all right, well, either x minus 5 equals 0, right, my first factor, or my second factor equals 0, right? At least one of those things has to be true in order for the zero product property to hold. So now I've got two super easy equations to solve here. So add 5. So x equals 5. Add 6, so x equals 6. So our final answer here is x equals 5 and 6. All right. Before we go on to B, another way to solve A would be to use the quadratic formula. And if we could not factor, you kind of have to use the quadratic formula, because the only other way I can think to solve this would be by graphing. But we want to solve it algebraically, right? Graphing is kind of a different way of looking at it, right? So if you want to solve this algebraically, and if you can't factor it, because again, most quadratics just randomly you can't factor them, you would have to use the quadratic formula. Now the quadratic formula always works, but you need to know it, and you need to be able to use it. So just as a real quick note, in this equation, our A value, our leading coefficient is 1. Our middle term is negative 11, and our constant is 30. So this would be our A value, this would be our B value, and this would be our C value. And in order to use the quadratic formula, you need to know x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And again, the nice thing about the quadratic formula is that it always works. But it's kind of a hassle if there's an easier way to do it. And in my opinion, I think that factoring in this equation would be the easier way to do it. Now, technically, if you use the quadratic formula to solve this equation, that's fine, right? It does not say solve for x by factoring. But anyway, two different ways of getting the same answer. I'm not going to show you how to apply the quadratic formula. If you want help with that, come see someone for office hours. But that's how we solve 6a, x equals 5 and 6. All right, B. For B, I have an equation 2x squared minus 162. Again, we're going to solve this by factoring, although I'll briefly show a different way of doing this. So notice, first of all, I have a leading coefficient of 2 on my x squared. However, I can easily get rid of it because my 162, well, that's an even number, so I can pretty easily divide everything by 2, right? And so I'm going to divide all my terms by 2, and when I do that, I end up getting just x squared in the first term. Half of 162 is 81. And then technically you do need to divide the right, but 0 divided by 2 is just 0 again. So the right doesn't change because 0 divided by anything other than 0 is just 0. So now I have x squared minus 81. At this point, there's kind of two routes you can take, or I guess 3 routes you can take. But I'm going to show, again, by factoring. That's kind of the gist of this entire question, number 6, is how can we use factoring to sort of answer, get answers to equations. So if you're going to factor this, I would encourage you to notice that what we have here is we essentially have something that looks like this. We have something that looks like something squared, okay, minus, now notice the number 81. The number 81 might kind of pop out at you because the number 81 is a square number because 9 squared is 81. So that makes 81 a square number, which means this could be written, and I'm kind of bouncing all over the place right now. You can write this as 9 squared, like that. So I'll continue with what I was doing up here in the top right. Notice that we've got something squared minus something squared equals 0. So at some point in a previous class, you almost certainly learned how to factor an expression like this, an equation like this. So notice that, first of all, this is key, we're subtracting. Okay, so what we're about to do here, this only works when it's subtraction. And then also notice that both of my terms here, the x squared and the 9 squared, they're both something squared. So this is something called difference of squares. And if you've heard that phrase before, then great. If you haven't heard it before, you're hearing it now. So this is something called difference of squares. And difference of squares factors in kind of a very sort of standard way, very sort of kind of predictable way. So when you have difference of squares, it factors into this. It's a plus b and a minus b. All right, and again, we're just setting this equal to 0. All right, so that's how you factor the difference of squares. Difference means the result of subtraction, and then what we're doing is we're subtracting one square number from another square number, and it factors into this a plus b, a minus b form. So for this question, we have x squared minus 9 squared, so I can factor that into x plus 9 and x minus 9. All right. Now, just like with a, I have a product. I have x plus 9 times x minus 9, and I get 0. The zero product property says that the only way that that can work is if at least one of your factors equals 0. So therefore, we have x plus 9 equals 0, or we have x minus 9 equals 0. And you can see, without too much difficulty here, that what you're going to end up getting is you're going to get x equals plus or minus 9. And that's our answer. All right, so x equals positive 9 and x equals negative 9 are both solutions to my original equation. All right, and if you want to move on now, feel free to move on. Technically, you could use the quadratic formula here, although that would be, I would call that kind of overkill to use the quadratic formula with a question like this. But the thing I want to point out here is that once you get here, okay, say or. All right. Once you get here, if you don't recognize this as being difference of squares, all right, I'll just rewrite my equation. All right. If you don't recognize this as being difference of squares, another way to solve this would be to try to just get algebraically just get x by itself. All right. So you end up getting x squared equals 81. All right. Now, to undo squaring, you need to use a square root. Okay, so if I want to get x by itself, on the left-hand side, I can take a square root, and when I do that, that's exactly what I want, right? I want x equals. But you can't just take the square root of the left-hand side, you have to also take the square root of the right-hand side, so we need the square root of 81. Now, I think a lot of you would kind of notice here that the square root of 81 is 9, right? So we get x equals 9. When you take a square root like this, right? When you say x squared equals 81 and you want to get x by itself, you need to introduce a plus minus after you take the square root. And the reason is because if I zoom in here, the reason you need the plus minus is because if you take a look at the original equation of x squared equals 81, well, you take x and you square it and you get a positive number, but you kind of lose the information about what the original sign of x was, because when you square it, you always get a positive. So if x was positive, when you square it, you get a positive. And if x is negative, you know, when you square it, that's a negative times a negative, which is a positive. So regardless of whether x was positive or negative, when you square it, you get an 81. So if you're going backwards and you're trying to get what x is, you need to introduce the plus minus because you don't really know whether x was positive or negative, because you're going to get a positive when you square it no matter what, right? So again, if you solve it in this method, that's fine, but when you take the square root, you've got to include the plus minus, because if you just say x equals 9, that is wrong, right? You need to include both answers of positive 9 and negative 9. Okay? So no matter how you do it, you get plus or minus 9. All right, C. So for C, we've got 3x cubed plus 6x squared equals 24x. So a couple things here. First of all, notice that 3, 6, and 24, they all have a GCF of 3, right? 3 goes into 3 once, 3 goes into 6 twice, and 3 goes into 24 8 times. So actually, because of that, you can make your life a little bit easier, kind of similar to what we did with B. You can make your life a little bit easier right off the bat if you divide everything by 3. Now, if you don't do this, you can still get the correct answer, right? So this first step is not, technically speaking, necessary. But if you do recognize that you've got a GCF here of 3, and if you just divide it out, it just means that you're just kind of dealing with smaller numbers, and just you're going to have to deal with the 3 at some point anyway, so you might as well just deal with it first. But again, if this was not your first step, that's okay, because it doesn't have to be your first step. But for us, I'm going to make it my first step. So divide everything by 3, and what we get x cubed plus 6 divided by 3 is 2, x squared, and 24 divided by 3 is 8x. All right, so that's step 1. Now, I want to solve for x, and in this case, I have to get all of my x's on the same side of the equation, right? So I'm not going to be able to solve this with x's on both sides. So I got to move this, what is now 8x, I got to move that to the left. I guess I could technically bring the 2 terms over to the right, but first of all, that you'd be moving 2 things, and you'd have a negative x cubed, and I just don't want to deal with that. So it makes sense to bring everything over to the left. And what you end up getting is you end up getting x cubed plus 2x squared minus 8x equals 0. All right. Well, notice that this kind of looks similar to A, in that I have a trinomial. I have 3 terms, and the power of x is decreasing on each term. But in A, it went squared, and then the first power, and then technically the 0th power. And now, but for C, I start with a cubed, and then a squared, and then a linear term. Well, I gave kind of a hint earlier. For all of these questions where we want to solve them by factoring, and whenever you're factoring, you always want to sort of check and see what's the GCF, right? What is the greatest common factor? Before you do any other kind of factoring, you want to try to factor out your GCF. So with x cubed, 2x squared, and negative 8x, well, the GCF here is they all have an x in common, right? We took care of the 3 earlier. Now, if you did not take care of the 3 earlier, you'd have to notice that the GCF is 3x. Okay, but we don't need the 3 anymore because we divided it out. So now our GCF is just x, and you want to factor that out to solve this problem. So our GCF is x, all right, and then when I factor it out, I end up getting x squared plus 2x minus 8 equals 0. All right. So now that leaves, inside the parentheses, that leaves me with a quadratic. Right? So x squared plus 2x minus 8. And as we saw in part A, if you want to solve a quadratic, you could theoretically use the quadratic formula, but this question is set up deliberately for you to use factoring. So our x is going to stay where it is. Then what's inside the parentheses is going to factor into, if from a single trinomial, it's going to factor into 2 binomials. Our leading coefficient on the x squared is 1, which means that this is just going to factor into x and x. Now, similar to A, I am looking for 2 numbers that multiply to the negative 8. They multiply to this term, and they sum to this number of positive 2. All right, so two numbers that multiply to negative 8 and sum to positive 2. Well, if they multiply and you get a negative number, well, the only way you can multiply two numbers and get a negative is if they're different signs, right? One has to be positive and one has to be negative, okay? And then they sum to positive 2, so they sum to a positive number. Well, if they're different signs and the sum is a positive number, it means that the positive number that you're trying to find, the magnitude of it has to be larger than the negative number, okay? So the positive number, the absolute value of it has to be larger than the absolute value of the negative number. So I would pause the video for a second to see, can you identify two numbers that when you multiply them give you negative 8, and when you add them give you positive 2? Those two numbers are positive 4 and negative 2. All right? 4 times negative 2 is negative 8, and 4 plus negative 2 is positive 2. Again, the zero product property says that when you have a product and you get 0, the only way that that can happen is if your factors equal 0, is if at least one of your factors equals 0. So here we have 3 factors. Okay? We have x times x plus 4 times x minus 2. So in order to solve this question, we just set each of those factors equal to 0. So our first factor was x, so we say x equals 0. Our second factor was x plus 4, and so we set that equal to 0. And our third factor was x minus 2, and so we set that equal to 0. Well, the first equation's done. The second equation, if you subtract 4 from both sides, you get x equals negative 4. And then the third equation, if you add 2 to both sides, you get x equals 2. So our final answer for C is x equals negative 4, 0, and 2. And the only other way to solve this that I can think of would be using the quadratic formula once you get the quadratic. Otherwise, you'd have to use graphing to get our 3 answers here. All right, D. So for D, we have a quartic. So we have x to the 4th minus 13x squared plus 36 equals 0. This kind of looks like A, and it kind of looks like the quadratic that we ended up getting in C. But notice that the pattern with the exponents is a little bit different, right? Instead of having x squared and then x and then a constant, we have x to the 4th, and then we have x squared kind of like in the middle, and then we have a constant at the end. So this looks similar to the questions that we've done so far, but it is in fact different. Whenever you have a construction like this, whenever you have like, you know, I mean, I guess in this specific case, you have if you look at your exponents, they go 4, 2, 0. What you can do is kind of like a little trick here, is you can say let we'll use the letter u. Let u equal x squared. And we're going to see why this trick kind of works, because notice that if I actually, you know what? I'm going to rewrite my original equation for a second. Notice that I can rewrite my original equation as x squared, right? Because a power to a power means you multiply, minus 13, and I'm going to kind of just introduce a set of parentheses here. Okay. So notice that if I actually no, I don't want parentheses there. That just makes it more complicated. But I'll you know what? I'll put parentheses around the whole thing. There we go. So notice that if I think of my original equation like this, well, I have something squared, and then I have minus 13 times something plus 36. Now this is kind of looking like a quadratic, because I'll rewrite what I wrote earlier. If you let u equal x squared, what you end up getting is you end up getting u squared minus 13u plus 36 equals 0. And some of you might be looking at this video like, why is he introducing u? Why is he introducing a new letter? Well, the reason is because if you let u equal x squared, you can rewrite the original equation as a quadratic, right? We now have u squared minus 13u plus 36. And we've now seen in this question several times how to solve this, right? You could use the quadratic formula, but again, the question is kind of intentionally set up to kind of steer you in the direction of using factoring, all right? So we get our standard setup here. There's no leading coefficient on, in this case, u, so we'll just have u and u, just like that. And just like the last couple of questions, what we're looking for is we're looking for two numbers that multiply to positive 36 and they sum to negative 13. Well, if they multiply to a positive number, it means they're the same sign. And if they sum to a negative number, it means that they're both negative. So we're looking for two negative numbers that when you multiply them give you 36, and when you add them together give you negative 13. Pause if you don't know what those numbers are. Those numbers are negative 9 and negative 4. All right, negative 9 times negative 4 is positive 36, and negative 9 plus negative 4 is negative 13. Zero product property says that each of our factors has to equal 0. So u minus 9 equals 0, and u minus 4 equals 0. Therefore, u equals 9, and u equals 4. All right. Now, if we were solving for u, we'd be done, right? Because u equals 9 and u equals 4. But the original problem, there was no u. We created u out of thin air, right? So now what we have to do is we have to go back and look at, well, what is u? U is x squared, right? Now, because we want to solve for x, not u, all right? So now I'm going to take my answers here. I'm going to sort of re-plug in for what u is, because u is x squared. So now taking this, and we'll just move up here. Well, now we have x squared equals 9, and we have x squared equals 4. And I want to get each of my x's by itself. So we're going to take the square root of both sides there and both sides there. So we end up getting x equals, now the square root of 9 is 3, but, and we saw this earlier, when you solve an equation like this with taking a square root, you don't know whether the original x was positive or negative, because no matter what, when you square it, you're going to get a positive. So because of that, because of the fact that x could have been negative, you need to introduce a plus minus here, because x could be 3, because 3 squared is 9, but it could also be negative 3, because negative 3 times negative 3 is positive 9. Likewise, when you take the square root over here, the square root of 4 is 2, but x 2 squared is 4, but also negative 2 squared, negative 2 times negative 2 is also positive 4. So our final answer here is x equals plus or minus 2 and plus or minus 3. And we get 4 answers. And notice that our original equation was a quartic. So it is entirely possible that you could get 4 answers with a quartic equation. Right? And in this case, we do in fact get 4 distinct answers: positive 2, negative 2, positive 3, and negative 3. And so that's question 6. We use factoring to get all of our answers, and there are alternative ways to get these answers. So if you got these answers using a different method, a different algebraic method, right? I'm not talking about using chat, I'm not talking about graphing, right? But if you used a quadratic formula or some other mathematically established method of getting these answers, the directions just say solve for x. So any mathematically valid way of solving this would be acceptable. But again, I would encourage you to take a look and make sure that you're comfortable with the factoring that we just did to solve this problem.